Hi, it's Jo Karen Hudson. In this video, we're going to be talking about rational exponents, or exponents that are fractions. So we'll start off with the definition of x to the 1 over n. What does that mean? Well, for any non-negative real number x and any natural number index n with n not equal to 1, uh, what that means is x to the 1 over n means the same as the nth root of x. Or if you had x to the 1/2, that would mean the square root of x. It's not necessary to put in the little index when it's a square root, but I sometimes put it in for emphasis. Or if you had x to the 1/3, that would mean the cube root of x. For any natural numbers m and n, and any non-negative real numbers x to the m over n means the nth root of x to the m. X to the m over n. The numerator of with the fractional exponent, the numerator is the power and the denominator is the root. Have the power over the root. Here's the root and here's the power. Find an equivalent expression for the given expression. So we have the fifth root of x, and the root is a 5, and the exponent is understood to be a 1, so we'll have x to the 1/5 power. The sixth root of 25, the exponent is understood to be 1, so we'll have 25 to the 1/6 power. When we have the square root of y, if there is no index showing, it's understood to be a 2. The power is a 1, so this would be y to the 1/2 power. Z to the 5th, that's understood to be a square root of z to the 5th. Now, where does the root go? It goes on the bottom, just like the root of a plant is on the bottom. This would be it's to the 5th power, and the root is 2, so it's z to the 5/2. Rewrite as a radical, 2 to the 1/4. Now, we know that the power is in the numerator and the root is in the denominator, so we're simply writing the fourth root of 2 raised to the first power, and we don't need to put the first power there. So we will simply be writing the fourth root of 2. Negative x raised to the 1/3. The negative goes out in the front. The exponent only goes with the base unless we've got parentheses. The way this is written, the exponent goes out in the front. The numerator is the power. The denominator is the root. So this is a cube root of x raised to the first power, or we could just say negative the cube root of x. Rewrite without exponents. 1/2 is the exponent. It only goes with the 16. There are no parentheses here, so we have negative. This is the power, this is the root, so it's the square root of 16. You can put the little 2 for emphasis if you want to, raised to the first power, or we could just say negative the square root of 16, which is 4. So the final answer would be -4. We know the numerator is the power, the denominator is the root, so this would be the cube root of 27 raised to the second power. The cube root of 27 is 3, and 3 raised to the second power would be 3 times 3, which is 9. Simplify the following radicals. Uh, the, the square root of 50. Now, if you think of your perfect squares, 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, and 5 squared is 25. I could actually rewrite this square root of 50 as the square root of 25 times the square root of 2. We know that the square root of 25 is 5, so I would have 5 square roots of 2. We will be in the habit of using our calculator to help us break down these radicals, though. From now on, we will be using the CPLX root program, and I will show you how to use that program. In the middle of your calculator, press Program. It will take you to this CPLX root program, so you press Enter, Enter, and then it'll ask you what root do you want. You want a square root, and the amount is a 50. The root is a square root, and you're trying to find the square root of 50, and you see that will give us 5 square roots of 2. So we'll be using the calculator to help us with these from now on. Okay, I'm going to bring up the cube root of 81 using my program, Math, CPLX root. So I'm going to do Enter, Enter, and it is the cube root of 81. Putting in a 3 because it's a cube root, and that gives us 3x root of 3. So when I write my answer, I must remember that what root it is. It's 3 cube roots of 3 is the final answer. Going on with the product rule, had the nth root of x times the nth root of y gives us the nth root of x times y for any non-negative real numbers x and y. I can use this in order to multiply and simplify the square root of 10 times the square root of 18. We know that they're both square roots. They have to be the same index. They either have to both be square roots or both be cube roots, or they have to have the exact same index. So if I have the square root of 10 times the square root of 18, I'll have the square root of 180 because 10 times 18 is 180. And then I'm going to use my program to simplify the square root of 180. If you're in it, just press Enter again and ask it what the square root of 180 is. The square root of 180 is 6 square roots of 5. So our answer here would be equal to 6 square roots of 5. Now I have the cube root of 3 times the cube root of 9, which would be the cube root of 27. And we know the cube root of 27 is 3. You can use your program to find that if you don't know it, or you can use Math 4 on that one. Simplify the following radicals. Simplify the following radicals. I have a fraction under the radical. I want to write them separately. Negative the square root of 25 over the square root of 49, which would be negative, the square root of 25 is 5, and the square root of 49 is 7. Now, you may have caught a glimpse of example 2 earlier. I had typed the wrong number under there and had to go back and fix it. I can use my CPLX root program to find out what the cube root of 216 is. Cube root of 216 is 6, and the cube root of 125 is 5. So this last example will be 6 over 5. This is Jo Karen Hudson. Thank you and have a wonderful day.